DHL in Finland has cooperated with us not just in ideal customer profiling, but also in deal scoring, which is another exercise we do by using advanced analytics. So we have a good data set. Thank DHL for that. Naturally, we are, as said, going to focus on the principles and not going to share any detailed information about the results, thinking of the nature of those. But a little bit background. So, like all the companies, DHL does prospecting in a formal manner, which means that they look up frequently new companies for their sales and marketing activities. And now the thinking is that how we can use the existing customer data to optimize it. And the data set we have received, we have of course received several, but in this case we were focusing on 1,000 plus existing customers, and for that we also narrowed it down based on the size of the customer to find out the good kind of benchmarks that, hey, these are the customers we really like. Then after that, once we have the company data, we used an additional service provider, Bainu, and we used all the available data points from Bainu and enriched the existing customer data beyond the original data set. And then we applied two different approaches to machine learning exercises to really drill down the nature of the ideal customer DNA. But if we take a little bit one step backwards, so in our world, this data set was in a sense still quite limited, since we was just focusing on the company data. Typically, we use the marketing data, prospects behavior, how they engage our marketing, how they behave on our website, how they behave in social media, etc. Then additionally, we've been using the contact data information you get from the leads, information on the opportunities, how the sales representatives has been acting, emails, meetings, calls, etc. So basically, there's plenty of different data sets to be applied in the optimizing or accelerating the customer acquisition. And today we just look at the very basics company data, as said, enriched with quite a few additional data sets. So here, just a simple illustration. So thinking that, hey, there's a big set of companies in your addressable market. They all have certain type of characteristics. What is the industry? What is the size? B2B, B2C, online companies, etc. But there's a certain profile, anyways, your prospects. Then once you start the sales and marketing activities, a subset of those companies are part of your sales pipeline, and that's already kind of interesting fact, because it already tells that what kind of companies are interested of your products and services. Then moving on, and some of them will turn to customers, and then you will also, then among the customers, of course, you have the best customers, your loyal customers, repeating customers, big customers, and that was our starting point. We looked into the data set and figured out that what is the kind of ideal benchmark when you are building the ideal customer profile. And of course, this approach, when you want to be very selective about the companies you want into your pipeline, it's definitely supports an account-based marketing approach where you want to kind of focus instead of having a shotgun trying to achieve everything what moves. You have figured out that, hey, what are the companies I really would like to see on my customer list? Well, when it comes to enrichment, we used Vainus data, Vainus API, which is a service they provide, and once we had identified the kind of best customers, we took those customers and enriched those with the Vainus data. And we weren't very selective. Practically, we did everything available, and that's just because of the nature of the exercise in machine learning. Anyways, the machine does the stuff, and humans can be blind about the certain firmographics data, which might be very meaningful in profiling the customer. So, as said, we weren't very selective. We just took what was there, and then we had the best customers with enriched data. And then you had the kind of data set prepared. Here you can see the exercise in a high level. So data preparation is always biggie, as we know. But now we had the data, and then we applied the kind of classical machine learning exercise. We just give all the data points and the customer kind of value of the customer, and based on those inputs, we did the first exercise to identify which features matters. And the latter exercise, approach 2, we used the kind of also machine learning approach, decision tree, which is a little bit different approach where you have you're constantly splitting your data set, and that's where you are kind of trying to kind of narrow down the optimal companies or practically not the companies, but the features of the companies. So, and as a repetition, the features typically looked when you do this manually, as we know, it's just the revenue, size of the company, location of the company, and industry. And if you go a little bit beyond that, then you can also look at the profitability. You can look at the growth of the company. Additionally, like Vainu has provided additional indexes, they calculate based on the data they scrape, so-called digitality index. So how much companies use different digital services and technologies. They also calculate social media index, how active companies appear in the social media. So these kind of additional indexes can also provided or utilized practically on both of the exercises. And this is the kind of broad and better what we do, and this was interesting exercise, even though I cannot share all the details we came out. But approach 1, there you see a screenshot, and there you see a different kind of variables So what are the regions which comply well with the kind of best customers? What are the industries, profitabilities, etc. And in addition to these features to be listed, they also have a weight. So how impactful individual feature is, and also how they correlate, are they kind of negative or positive when it comes to building an ideal customer profile. And this is very useful. It gives you the kind of explicit idea that how it goes. Of course, you need to have some volume in the data. I mean, if you, for example, try to use the region as an ideal customer profiling, you of course need to have enough customers, enough sales cases in all the regions in the scope. And this is an iteration, so you get some results, you look them, machine provides you the results, you look them, and then you try to figure out how it really applies to real world, and then you might do another iteration with the kind of more given variables that, hey, use only these features in the next calculation round. Moving on to the second approach, the decision tree, and here we have a simple illustration, and very much the same applies here. This is a little bit more useful and as easy as the previous approach, but the value here is that instead of just providing individual features that, hey, focus on this, decision tree gives you also the relation. So if you are in a certain industry and then you start narrowing down, hey, what about this industry? And once you move on to different variable, then it gives you that, hey, if you are in this industry, then your turnover should be on this in this bucket. And if you are in this industry and your revenue is this size, then what is your, as we have here in an example, what is your digitality index, etc. So you can build the kind of profile buckets based on this. And nevertheless, even though machine is doing the kind of heavy lifting, the calculating what are the odds, what is the weight of individual feature and how they relate, you still need to validate them with your own eyes and have an additional round and again maybe cut off some of the features in order to get additional insights and build additional profiles, because in a sense we are not just looking for one ideal profile, we are looking for multiple, because as we know, all the businesses have different kind of customer segments, and with these classification exercises you can dive into those. And the results, what do you get? So it's very obvious. Then you get the different kind of sets of firmographics to be applied in your prospecting process, and then you can, for example, use this Vino service and just key in on the filtering that, hey, give me companies on these industries with these revenues, with these digital indexes, etc. So then you get a one batch of companies for prospecting process, and then you can do it again with the other industries, with the other revenue sizes, with other digitality indexes, and basically once these features of the individual companies are optimized, so basically, of course, your customer acquisition process should be accelerated, meaning that whatever sales and marketing activities you do, the response will be better. And after all this, just a simple wrap up. So this was kind of a one-off exercise. Of course, you can do it with the more automated manner, depending on the frequency and size of the prospecting activity. So since current CRMs, they have APIs you can utilize. Our service has an API you can utilize. Vainu provides API, you can pull the data. So it, of course, requires supervision, but still you can automate the process on certain length. So what we had here, of course, was the sales pipeline, historical sales pipeline data from the past 2 years. Then we were using the API, which is a subscription-based service. Then we used both RStudio and Microsoft Azure machine learning service to do the calculation runs, and then roughly, since the data set was pretty well known to us, we used roughly 2 days of work in order to carry out this ideal customer profiling.